like see me and stuff? Okay. All right. Cool. All right. Okay. So we're going to go forward and assume everything is working out okay. I'm going to have my Google Slides up, so you guys, if there's an issue, I'm going to need you guys to interject and let me know that something's up. Okay. The target check from Friday, the week 9 target check, I want to go over that. And then we're going to talk about the layers of the atmosphere. So first off, test retakes. If you took the test retake on Friday, or if you did the makeup, it should be graded and it should be put into MyStar. Okay. If you have any questions, let me know. All right. Retakes. The last chance to take test 1 for a retake is this Friday. Okay. You do have to have 3s on your target checks, but at this point, you can't retake the target checks anymore. All right. So if you don't have a 3 on all of those target checks, you're out of luck. All right. That's too bad. It's frustrating, I know, but at this point, we're moving past that. If you do have a 3 on all your target checks, you're still eligible to retake it this Friday. It'll still be the same thing. It'll be at 1 o'clock. You'll meet me on whatever video meet thing that we're going to be able to have access to. Hopefully it'll be Canvas, but it might be Google, because who knows. Okay, so just wanted to remind you of that. And if you did retake it, it's graded. If you made it up, it is also graded. It should be in there, so take a look at that. All right, so the week 9 target check. So this is the question. Hold on, something's come up. Whoa, did you see that? There was like a drive-by yawning. It just went right by. Anyways, question 1, it says the current measured amount of carbon dioxide is 416 parts per million. That's like up to date as of this past month. All right, so that is the highest it's been in hundreds of thousands of years, which we'll talk about a little bit more as we get into the semester here. But my question in this is, what does parts per million mean? And what ppm means is quite literally how many of those molecules are there per million. So if it's 416 ppm, that means out of 1 million molecules, 416 of them on average will be carbon dioxide. So the answer I was looking for there is, for every million molecules of air, on average, 416 of them will be carbon dioxide. So in this case, it was this answer here. I know a lot of you were tempted by this answer, picture perfect, Mr. Bowsy, but that's actually not the answer. A lot of you were really struggling with that. Sorry for the confusion. All right, so question 2 is dealing with the greenhouse effect. And I wanted you to just kind of throw in, there was choices for each of these spots. But here's the short and sweet for the greenhouse effect, folks. This is a phrase that comes in handy when you're trying to understand how our atmosphere is heated. All right? And the short and sweet is this, is that the sun heats the earth with visible light. Right? The sun gives off mainly visible light, travels through space, no problem. Travels through our atmosphere, no problem. And it goes all the way to the Earth's surface where there's a problem. It gets absorbed, right? We know that if you've ever walked on a blacktop without any shoes on a sunny day, it hurts. The sun, the light from the sun is absorbed by the Earth's surface, right? And when light is absorbed, the energy is transferred to the new substance. So the surface gets energized. And as a result, the temperature goes up because you're adding kinetic energy now. Molecules are going to move faster. All right, and when something gets hot, it gives off heat. And that's what the Earth does. It gives off infrared. It gives off heat. The problem with infrared is it can't go through our atmosphere. Visible light can go right through. Infrared can't. So the sun heats the Earth gets hot, the Earth gives off heat, that heat gets trapped in the atmosphere. That's the greenhouse effect. Sun heats the Earth heats the air. Sun heats the Earth heats the air. Say it with me. Sun eats earth, earth eats air. Did you say it? Yeah. I'm going to go with yeah, you did. All right. Let me do question 3, and then I'll stop and see if you guys have any questions on any of these so far. All right, so what happens to the temperature of the air as you increase in altitude? This is based on the that layers of the atmosphere thing we were working on. Hey, we're going to talk about this one today, okay? But the answer is it fluctuates. It gets colder, it gets warmer, it gets colder, and then it gets warmer. All right? Air pressure, though, is always decreasing. Doesn't matter what the temperature is doing, okay? So real quick, I'm going to stop and see if you guys have any questions. Any questions? William, that picture of that cat is hilarious, by the way. So funny because I haven't seen any of your Google, like profile pictures. Savannah, that's a great picture. Awesome. That's cool. Anyways, you guys have any questions?
Okay. No questions.
Awesome. Thank you. All right. So question 4, we had some issues. All right. And it was a tough question. So choose the best definition or explanation, whatever, that fits the word itself. So the word heat itself is actually a reference to infrared light. Infrared is energy. It's a type of light. We can't see it, but we can feel it, right? And when we feel it as warmth. So a lot of people put the answer warmth here, which makes sense, right? But what heat actually is, it's not warmth. What heat is a type of light, right? Infrared. Temperature measures the speed of the molecules, right? So it's the average kinetic energy of the molecules in a substance. How fast are the molecules going? So therefore, if you have a thermometer, which measures temperature, what the thermometer is actually measuring is the speed of the molecules. So it's really a speedometer, is what it is. Last question, and there was another one after this. The true and false questions were me just making sure you know that I'm kind of an idiot sometimes, okay? First one was, Felix Longbottom died attempting to jump from 24 miles up. Folks, that is false. He did not actually die. I know this probably comes as a shock to you, but I stretched the truth a little bit. He actually lived. Now, he didn't grow wings. That part was true, okay? He had a parachute, turns out. But anyways, he did not die, and he was also not related to Neville Longbottom, okay? He had no relationship to Neville Longbottom, and I have a weird sense of humor, and that brought me great joy. So, anyways, there's that. Questions? So, to sum it up, he jumped from 24 miles up. When he fell, he actually fell faster than the speed of sound, and he survived and lived to tell the tale, and confirmed that Red Bull does not give you wings. Okay, I talked a lot so far. One more chance to give you an opportunity to ask me a question. Okay. Okay. Can you guys see this beautiful graph?
No, we can't. Oh, never mind.
Can you now?
It just says loading.
Oh, okay. Let me know when it pops up.
The graph is on the screen now.
Okay, awesome. Thank you. Okay. So you guys hopefully should recognize this. This is the activity we did last week. And it's the layers of the atmosphere, okay? So what I want to do is I want to talk about why the layers are doing what they're doing, okay? Now, I was going to do this on Canvas, which I'm way more comfortable with and familiar with, but now I have to do this on this particular format, so this might not go quite as well. But I'm going to be writing some things down here. These are basically like your notes, okay? But what I want to ask before that, and I want you to write in the chat your best answer that you possibly can give me, is there are two acceptable reasons or two acceptable explanations for why it gets cold in the troposphere when you go up. So if you look here, this is the troposphere. This is the layer of the atmosphere we live in, right? On average, the surface temperature is 15 degrees Celsius. But as you go up, it gets colder and colder and colder and colder and colder. So my question is, why does it do that? All right, so can you guys write in the chat, why does it get colder as you go up in altitude in the troposphere? And push enter whenever you're ready. Good. Awesome. Okay. Some good answers. Good, Liz. Thank you. Okay. So there are two acceptable answers, and it looks like we're hitting on both of them there, right? One of them has to do with air pressure, and one of them has to do with that whole greenhouse effect we were just talking about a second ago. Okay. So, ladies and gentlemen, I'm going to ask you to do something. This might be painful for some of you, but I'm going to ask you to turn on your camera, please. Would you please turn on your cameras for just a second? Not literally a second. It's going to be like a couple minutes, but then you can turn them back off, okay? Davey, that is totally appropriate background. I love it. Talking about the atmosphere, it's good stuff. You guys are going to have so much fun. This is awesome. This is the best. Kayla, nice forehead. Looking good. All right. Leora, thank you. All right. Okay, so here's what I want you guys to do. Okay. We're going to do, and this is, I'm glad you guys don't have masks on because this is really hard to do when there's a mask on. But what I want you guys to do is I want you to put your hand in front of your face like this. Okay. And I want you to act like you're checking your breath. You don't actually have to check your breath. You're welcome to do that if you want. But I want you to just blow into your hand like you're checking your breath, like this. What's it feel like?
Warm.
Feels warm, right? Because, folks, I have good news for you. I hope you're sitting down. And the fact that your cameras are on, I can tell that you actually are sitting down, so that's good. You guys are hot. Don't you love it when teachers tell their kids that they're hot? Isn't that such a nice thing, right? But you are. You guys are all hot, all right? So take that, just take that and just feel good about it for a little bit, all right? You guys are 100 degrees Fahrenheit, roughly. You are literally hot. And so when you exhale, your internal body temperature is what you're feeling on your hands, right? It feels warm because it's warmer than the air that you're in, right? Unless your house is 100 degrees, which would be really weird, by the way. But anyways, that's the case. All right, so two things. One, you're hot. I want you to know that. And two, the internal body temperature of your, the air that's coming out of you is very warm. Okay, so now what I want you to do, you're going to put your hand in front of your face, the same spot, okay? But you're not going to check your breath this time. You're going to pretend like you're whistling for the first time and you have absolutely no idea how to do it, and you're just blowing all over the place like this, right? Do it, folks. This. You have your camera on because I want to see you guys do this and be idiots with me. Come on, it's not fun unless we all do this together. All right, Liz, I know you already did it. I want you to do it again. All right, Brennan's cat, you better check your breath, dude. I'm not lying right now, bro. Get that paw in front of your mouth. Landy, the ghost that's on the ceiling there should also be doing this. Okay, what did it feel like when you blew into your hand like that?
It felt cooler.
It felt cold, right? Did you suddenly like die and become a zombie? And are you just suddenly not hot anymore? Like what happened?
A little lightheaded, but
That's a good point. All right, you guys, thank you guys for having your camera on. You guys can turn it off now if you want. I do really appreciate it though. Why did it get cold? Anybody? Why did it get cold? Anybody know? No? Let me show you something else. Have you guys ever seen one of these things before? Am I really blurry right now? You guys gotta let me know this.
a little bit, yeah.
How's that? Is that better?
Yeah.
Yeah. It's probably best that I was blurry, but no. Anyways, have you guys ever seen one of these? You know what these do? These are like compressed air cans, right? So this is gonna sound a little windy. Okay, so it's just a compressed air can. So there's compressed air inside this can, and what you do is you clean your keyboard with it, right? Like, ah! And I just have fun with it, and I usually waste it because it's so much fun. But anyways, I only turned on this spray can for about 3 seconds total, maybe, and I can already feel that the can itself is significantly colder. Plus, if I hold my hand here, the air that's coming out feels cold, right? But here's the thing, folks. This can has been sitting in my desk drawer quite literally for a couple years now, okay? It is exactly room temperature because it's been in my room for 2 whole years. But when I feel the air coming out, it feels cold, right? And when I run this for a long time, the outside of the can feels cold, right? What's happening? Why is that happening? Aha! Jacob, nice. Liz, nice. Okay, perfect. So folks, when you do this, when you're trying to whistle for the first time, you got your lips, you're pressing your lips up like this, right? And you got your lips really compressed into a tiny little, little space. The air molecules that are coming out of your lungs are getting compressed together in between your lips. And when they come out of your mouth, they rapidly expand, meaning the distance between the molecules gets farther away, right? And I'm sure you guys remember your chemistry, right? When you decrease pressure, what happens to the temperature of a gas? Thank you, Jacob. Appreciate that. Yeah, when you decrease air pressure, folks, decrease air pressure, decrease the pressure of a gas, you decrease its temperature, okay? So in the troposphere, going back to this, right, you decrease, this is a little big, I might have to, decrease air pressure, decrease temp, okay? That's what's happening in this first layer here. Give myself some more room to write. Okay. So that's one reason why it gets colder as you go up. The second reason is, remember, the sun heats the earth and the earth heats the air. The farther up you go, the further you are away from the heat source. Okay. So there's the troposphere. Okay. As you increase in altitude, you decrease in temperature because the air pressure decreases. All right, folks, next question for you. In the stratosphere, is the pressure of the air still decreasing? Because if you look at the graph, the temperature is warming in the stratosphere. So is the air pressure decreasing? Landy says no. Okay. Well, let me refer you back to this question here, right? What happens to air pressure as you increase in altitude? It decreases. It always, always, always decreases. So is the air pressure decreasing the reason why it gets warmer in the stratosphere? No, that doesn't make any sense. The air pressure is still decreasing in the stratosphere, but somehow it's still getting warmer. And Elizabeth says it's because of the ozone. What does the ozone do? Yeah, what radiation specifically? What does the ozone protect us from? Yeah, thank you, Jacob. Thank you, Liz. Yeah, the ozone layer protects us from a type of light that we can't see, right? But is, harmful to us because it has such a high energy, it can actually penetrate through the epidermis of your skin, the top layer. And when it does that, it can actually hit skin cells in certain ways and can kind of create a cancerous effect, right? But ozone protects us from that ultraviolet radiation, okay? So what I want to add for the stratosphere here is I'm going to talk about why it gets warmer despite the fact air pressure is decreasing. So I'm going to start by that. I'm going to say air pressure is still decreasing. Okay. But in spite of that fact, in spite of the fact that air pressure is decreasing, the temperature still warms up, right? So as you go higher in the stratosphere, the temperature gets warmer and warmer. And that's because ozone molecules, right, which is actually O3, it's 3 oxygens, right? 3 oxygens bonded together. O3 absorbs ultraviolet radiation. And folks, radiation is a type of light. It's light. And so if O3 is absorbing ultraviolet light, the energy from that ultraviolet radiation is going to get transferred to the ozone molecules. Their energy level goes up. And when you increase the energy level, the molecules move faster. The temperature increases. Okay? So this increases the kinetic energy, right? So molecules are speeding up. So the temperature goes up. Okay? Make sense? Okay. Then it stops and turns back towards the cold, right? This last layer is the mesosphere. Why does the mesosphere get colder? Anybody? Why does the mesosphere get colder? So far, you're not wrong. Well, it doesn't, you're right. Because remember, the sun is visible light. The light from the sun is visible. So it's going to go through the stratosphere, the mesosphere, the thermosphere, everything, right? So that is true. But my question is, you know, it starts out warm here because the ozone layer warmed it up below, and then it starts to get really cold. Why does it get so cold? It's actually the coldest layer, right? So this is the coldest layer, right? Why is the temperature getting so cold? Same reason as the troposphere, right? Air pressure is decreasing. And when you decrease air pressure, you decrease temperature, right? This is the coldest layer because this is where we have the lowest atmospheric pressure plus no molecules absorbing any energy from the sun, okay? So this is the coldest layer. This is a relatively boring layer because there's not a ton of stuff going on in this area. One thing it does have that I think is worth mentioning is this is the layer where meteors take place. What's a meteor? You might know. I don't know, like former astronomy student would make me really proud if he knew the answer. Not talking about anybody in particular, but it would be nice if a former astronomy student knew what a shooting star is. Oops, gave it away. Meteors are shooting stars, and a typical shooting star is only a piece of space rock roughly the size of a grain of sand. It's a really tiny space rock that crashes into our atmosphere and gets so hot it vaporizes and turns into a gas, right? And when that happens, it produces light. So a typical shooting star is made from a space rock that's super small. Every now and again, you can get bigger space rocks that crash into our atmosphere, and a portion of the rock actually makes it to the surface, and that's what we call a meteorite, right? Well, we talked about those already. So just wanted to mention that. Okay, the last layer. I'm going to write down some potentially confusing statements. All right, so look forward to that. I'm going to change it to red so it stands out. This is the thermosphere. All right. So thermosphere, it starts to get hot again. Okay. It can actually reach 1,000 degrees. All right. It can reach 1,000 degrees in the thermosphere. But folks, the thermosphere, this is where the International Space Station is found, right? If you were to float around in space outside of the International Space Station, the atmosphere is technically 1,000 degrees, but would it feel warm to you?
It wouldn't feel warm because it's kind of like the teacup thing. So one air molecule would be 1,000 degrees, but because the air molecules are spread out so much, it would feel colder.
Hannah, you have revived my faith in your generation. All right? Good job. That's exactly right. So I'm going to write down some really weird sounding phrases, but they're all just tricks to help you remember some of the basics here. So technically it's 1,000 degrees in the thermosphere, but you would freeze, right? It's hot, but it's really not, right? And the reason is exactly what Hannah said, but I'm going to say it in a way that has a little bit of like a mnemonic trick to help you kind of remember later on. But it's hot, but it's not because the air is rare up there. Okay? So the thermosphere is a confusing layer because technically it's the hottest layer in our atmosphere, right? But it's really not because it doesn't have the most energy. The troposphere has by far the most energy because it has by far the most molecules. And the molecules are what are holding on to that energy. The thermosphere is basically space, right? Yeah, they're really hot. Each molecule is really hot, but you have one molecule there and you have another one way over there, and there's nothing in between them, right? So the air is extremely thin. So it's not really going to feel hot, okay? So this is where the teacup versus the bucket comes in handy, all right? The thermosphere is the teacup. The troposphere, which is where we live, is the bucket. Okay? Questions, anybody? Anybody?
No, that's it.
Good. Okay. Couple things. One, I don't have an exit ticket written yet, I don't think, because I think I was in the process of doing that when Canvas crashed. I'm not even sure if I can get onto Canvas. Let's see what happens, y'all. It appears to be working okay now. All right. So what I'm going to do is I'm going to unlock the exit ticket for you on Canvas, and that's it for you today. I don't have any other items for you to do. I just wanted to check in with you regarding the layers of the atmosphere assignment, and then that's it. Do you guys have any last minute questions or concerns? After you finish exit ticket, if you want to stay on and ask me questions about your grade, we have 10 minutes. That would be a good time to do it. So let me post the exit ticket really fast, and then you guys will be good to go. Okay, if you guys refresh the Canvas page, you should see the exit ticket for today. Real quick reminder, folks, if you are a senior, you do not have school tomorrow or Wednesday. If you are a junior, you have SATs tomorrow and Wednesday. If you're a sophomore, you do not have school tomorrow, but you have school Wednesday, right, where you'll be taking a test. And then if you're a freshman, you have school tomorrow, but not Wednesday.
Mr. Bowsy,
Mm-hmm.
I have there's no submit option for the.
Oh, because I went too fast and I screwed it up. Okay, hold on. First mistake of my teaching career. Shoot. Can't believe that happens. All right. Refresh. It should be good now. Liz, it's a cute little kitty. Noah, that's a cute little baby. William, that cat is terrifying. I'm not gonna lie. I might have nightmares from that thing. Landy, you can leave, but only if you don't really want to.
Mr. Bowsy?
Yeah.
So one second, hold up. So since I haven't taken the retake and the grades are going in the grade book, you said tomorrow.
Mm-hmm.
So how would that work?
So what I would do is
Would you drop it for just until Friday, or?
So what I'm going to do is on Friday after you take it, I'll put it in immediately, and then I'll submit a grade change with the district. So it won't go on your transcripts.
Oh, okay. All right. Thank you.
Yep.
Thank you, Mr. Buzz. Have a good rest of your day.
Thanks, Felipe. Take care.
You too.
Have a nice day, Mr. Bowsing.
Thanks. You too, guys and gals.
Mr. Bowsy,
Mm-hmm.
I have like a sort of hypothetical question.
Sure. What's up?
So, if you were in the thermosphere and like even though there aren't many air molecules up there because of low air pressure, wouldn't it still feel like little little warm specks are hitting against your skin or something like that?
It's a great question, and you might feel a sensation like that. But in all honesty, the reality is, one, you're losing way more heat than you're going to get from that one little molecule transfer of energy. And two, you have so many other things going on to your body that you wouldn't feel that, because you would be under so much tremendous pain from other things that are going on. But yeah, that's a great question. Hypothetically, you might feel a little bit, but you're losing so much more than you're gaining. Overall, you'd feel extremely cold.
Okay.
Mhm.
All right. Thank you.
Yep.
Have a great day.
Oh, and Elizabeth, it's kind of like, have you ever put your hand like through a candle or something really fast? Where you like quickly go through it. It's kind of like that, where it happens so fast that it's not something that's noticeable.
Though I have had like bubbling oil popped out of the pan and
Okay, that's different because it sticks on your hand, right? And that hurts. Yeah,
But
that's different.
it's sort of the same though.
Yeah, I guess you're kind of right. You're kind of right.
Mhm.
Good question. All right, bye, y'all. Thanks for adjusting today.